Yeah, so once you have your solutions ready, email them to me. You have my email address, it's on the syllabus.
Yes.
Yeah, so just email them to me, attach as a Word document your solutions, and then email them to me.
Okay.
Since you just got your book, you'll probably need some more time. So I can extend the deadline, for your sake and also for the sake of anybody else that might need extra time, to next Sunday, and I'll put that on the chat as well.
Okay, thank you.
Yeah, sure. Do you have any other questions? Are we good?
Yes, it's good. So, okay, you said after each chapter, make the exercise, but specifically, we send 3 of them, right?
Yes. Today's lesson is on ratios, proportions, and percentages. So lesson 1 focuses on ratios, and there are several key ideas that the book opens up with. A ratio has 2 terms, and it can be written in words, it can be written with a colon, or it can be written as a fraction. So for example, 3-1, let's say on the GED, you see a question that mentions something along the lines of, if a baseball player's batting average is 3-1, that means for every 3 throws, he hits 1, right? You can write that same ratio with a colon. So you would write 3:1, or you can write it as a fraction 3/1, okay? Ratios are also simplified by reducing to the lowest terms, as we've seen with fractions. And then the terms in a ratio can have different labels. And we'll see that as we progress through today's lesson. So a ratio essentially compares 2 numbers. You can write a ratio using a word, using the word 2, as I explained, our baseball player with a ratio of 3-1 bats. You can use a colon, and then you can also use a fractional form. So a softball pitcher strikes out 4 batters for every 1 batter that she walks. What is the ratio of strikeouts to walks? And so you always want to write the number in the ratio in the same order in which they appear in the question. So here, we're being asked, what is the ratio of strikeouts? We're told that she strikes out 4 times. So you would write your ratio 4-1. These are the 3 different ways that we've talked about, either 4-1, 4:1, or 4/1. Okay.
Okay.
So in this example, we're being told that Frank manages a small drugstore during a 2-hour period, and he counts 25 cash sales and 15 credit card sales. And we're being asked, what is the ratio of credit card to cash sales? So again, you want to pay attention to the order in which the question is asking you to present the ratio. So what is the ratio of credit card? You look into the details provided in the question and look for information on credit cards. How we see here 15 credit card sales. What is the ratio of credit card to cash? We see that he counts 25 cash sales. So how are you going to present your information? As either 15/25, 15/25, or you can write down the statement, write down using a colon 15:25, right? So here's our ratio. And now we want to reduce that ratio to the lowest terms. And we can quickly recognize, looking at 15 and 25, that they share a common multiple of 5. And so you would divide 15 by 5, which gives you 3, 25 by 5, which gives you 5. And now we have our ratio in its lowest terms, 3/5. Okay. And again here, I'll just mention, as you're studying, as you're getting ready, write out the multiplication table. and memorize it so that you can easily recognize multiples when you're working on the test. You could also just put this in your calculator, but it will take a lot of time for you trying to, well, there's actually a fractional operation in your calculator that lets you deal with ratios. I'll show you that later down the line. But I do suggest that you memorize the multiples table so that you can check yourself, because sometimes, you might enter the wrong value in your calculator, for example, and you need to be able to know, wait, that doesn't look right, right? So the book also suggests this, and I strongly agree. Memorize the multiplication table so that as you're working on fractions and ratios and percentages, decimals, division, multiplication, it really comes in handy when you can quickly access that information in your head without having to reach for your calculator, because sometimes, human error, you're nervous on the test, you might put in the wrong value, and you need to be able to check yourself. So just keep that in mind as you're working on these. So there are some fraction rules that ratios do not follow. So for example, don't change a ratio that's an improper fraction to a mixed number. Also, if a ratio in a fraction form has a denominator of 1, do not write it as a whole number, because that 1 is significant and is important as you're working through the problems, and you'll see that as we continue on with today's lesson. So you want to leave it in fractional form, okay? The terms in a ratio must be written in the order given by the words of the question, as we saw earlier. And that's always a good sort of a good thing to keep in mind, that helps you know that you're answering the question correctly, because you're following the same order as the question asking of you. So don't be fooled by an answer choice on a multiple choice question that reverses the order of numbers, okay? You want to pay attention to how the question is asking you to present the information and present your answer based on what the question is asking you, okay? Don't reverse the order. And we'll see lots of examples of that again today as we progress with the lesson. So another important difference in the use of labels is in the use of labels. So the terms in a fraction have the same unit labels. 5/6 of a pie means 5 slices out of 6 slices. Ratios may have different labels. So a sale advertised 6 cans for $1. The ratio would be 6:1, okay? So to write a ratio, you may need to perform one or more basic operations to find one of the terms. In this example, we're being told that a football team won 12 games and lost 8. And there were no tied games. So what is the ratio of games won to games played? So again, you want to present your information based on what the question is asking you. What is the ratio of games won? We look here that they've won 12 to games played, right? And if you look in the question, the problem doesn't tell you the number of games that was played. We just know that they won 12 games and they lost 8, right? So if they won 12 times and they lost 8 times, it means that they would have to have played a total of 12 plus 8 times, right? Which is 20. They would have had to have played at least 20 times to be able to win 12, okay, and lose 8, right? So the first step with this question is adding 12 plus 8 to give us 20. And then you want to write the ratio in the correct order and simplify. So the question is asking you, what is the ratio of games won? We know that that's 12, right? They've won 12 to games played. We know that that's 20, right? So you would write your ratio as 12/20, and then you should immediately recognize that 12 and 20 share a common multiple, which is 4. So you divide 12 by 4, you get 3. 20 divided by 4 is 5, and you can give your answer that the team won 3 games for every 5 games that it played, or a ratio of 3-5. Okay. Again, the same sequence that we're following with chapter 1 and 3. The first lesson on ratios, there are practice exercises starting on page 683 to 688. And if the page numbers are different in your textbook, obviously you just go ahead and work on the problems wherever they start in your book. Don't worry about not having the exact same page numbers. All right, so on to proportions then. Proportion is essentially an equation that shows that 2 ratios are equal. So the cross product of 2 proportional ratios their cross product will be equal. So in other words, when you multiply diagonally across the equal signs, the ratios will be equal, and we'll see examples of that as the lesson progresses. So here is, in this example, we're being told that the directions on a can of powdered drink say to add 3 cups of water to every 2 scoops of drink mix. Matt adds 12 cups of water to 8 scoops of drink mix. So let's say he's trying to make the drink for his family members, okay? Did he make the drink correctly according to the instructions? Because let's say maybe the drink is it has some medicinal value, so you don't want to overdose your family members, right? So you want to make sure that even though you're making a large quantity, you're not making a single serving, you're making enough for several people. You still want to make sure that you're proportioning it according to the indications, right, on the drink bottle. So the first thing that you're going to do is you're going to write a proportion, making sure that the terms and the ratios are in the same order, right? So it's saying that the way that you add the drink is that for every 3 cups of water, you need to add 2 scoops of the drink mix, or 3, 2, 2, right? It tells you right here. So you would write your ratio in terms of cups to scoops. So that's 3 cups to 2 scoops, right? And then it's saying that Matt adds 12 cups of water to 8 scoops, right? So these are the directions on the bottle, and these are the number of people, let's just imagine, that Matt is trying to share the drink with, okay? So 3 to 2 is equal to 12 over 8, right? Because the 12 cups of water, he figures, will be enough to cover all the people that he's trying to share the drink with. And he's going to need about 8 scoops of the drink mix so that it tastes correctly and it has enough concentration to heal whatever it is that whatever ailment that they have, we're imagining, right? So we're equating 3 over 2, the instructions, with the number of people that he's trying to share the drink with. So we're saying essentially that 3 over 2, 3 cups to 2 scoops is equal to 12 cups of water to 8 scoops, right? And so what we want to do then is cross multiply, right? To find out if he made the drink correctly, we're going to cross multiply. 2 times 12 is 24. 8 times 3 is 24. And since we have equal products, we know that he has he's made the drink correctly.
Correctly.
Okay. So again, all you're doing is cross multiplying to make sure that you get the same number. And if you get the same number, then you know that these proportions are the same. Okay.
Okay.
And you can maybe consider I mean, I'm sure it's pretty clear, right? Like, let's say,
Okay, clear.
yeah, okay, good. Jaleesa, you okay?
Yeah, I'm good.
Okay,
I'm following along.
okay. So in most proportion problems, you're going to be asked to solve for a missing term, right? So in this example, a map scale says that 2 inches equals 150 miles, right? So let's say you're looking on your iPhone and you're trying to figure out the distance from here to, I don't know, from Dallas to Houston, okay? And it's telling you that 2 inches on your phone, on your phone's map, is the equivalent of 150 miles, okay? What is the actual distance? What actual distance would a map distance of 5 inches represent, right? So if you saw 5 inches on your map, how many miles is that in real life? So what you're going to do, again, you're going to start by writing your proportion in terms of two ratios. And we're dealing with inches to miles, right? So what is the actual distance? A map of 5 inches, so it mentions inches first, so you're going to write down your inches first. A map of 5 inches, what distance would that represent in terms of miles? So write down your inches to miles. We're starting off with 2. The problem tells us that every 2 inches is the equivalent of 150 miles. So you're going to write 2 to 150 is equal to 5, right? Because it's asking you what is the distance that 5 inches, so that's equals to 5. What distance would that represent? Well, we don't know the distance, so we're going to represent that distance with x, right? And again, as I explained several lessons ago, if you remember, x here just means that we don't know what this value is, but we're going to find out. We're trying to find out, right? But we can't just leave the space empty. So we're going to represent it with a number, or we're going to represent it with a notation that indicates that this number is unknown, or that it varies. So x here is a variable, and it represents the unknown distance, right? So once you've written your proportion in terms of ratios, inches to miles, you're gonna then locate the first term in the ratio that is diagonal from the known term in the second ratio, right? So our first term in the ratio that is diagonal is right here, right? And you would cross multiply, as we saw in the other example. So 150 times 5 gives you 750. And then you would also cross multiply. 2 times x gives you 2x. If we had 500 here times x, you would have 500x, right? So whatever you multiply, whatever number you multiply your variable with will be that number times the variable, essentially, right? So here we're multiplying 2 times x, so we'd have 2x. So our equation would look something like 750 equals 2x. And what do we do to find x? Remember, we talked about changing the subject, I think it was in chapter 2, right? Since we're looking for x, we're going to divide both sides of that equation by 2, right? So on the right-hand side, where we have 2x, we're going to divide by 2. 2 divided by 2 is 1. So that leaves us with x, which is what we're looking for. On the left side, we're going to divide 750 by 2. 750 is 375. And so 375 equals x, right? And so now we have our quantity, and we also have our answer. On that map, 5 inches represents 375 miles. Okay, so again, all we did was write down the information in terms of two ratios. The first ratio containing information from the problem, information that we have from the problem in terms of the number of inches that equate to a certain number of miles. In this case, it's 2 inches or to 150 miles. And then you're going to equate that to the number of inches, the new information that's being asked of you, 5 inches, to the distance that you're looking for, which in this case is X, right? And so now we have here our proportion. So if you're on the question, if you see that they're asking you for a proportion, know that there are two ratios involved, right? Here's our first ratio, and here's the second ratio. And then what do you do to find X? It's very simple. You just cross multiply, okay? So 150 times 5 is 750. 2 times X is 2X. So you're going to have 750 equals 2X. Because again, remember, we're saying that the two proportions are the same, just like with our drink, right? We equated 3/2 with 12/8, the number of people that are going to get that drink. In this case, we're trying to find out if the number of inches increases on the map. How does that play out in real life in terms of the number of miles, right? So 750 equals 2X. You divide both sides by 2. Again, anytime that you have a variable, the first thing you want to do is isolate that variable. And we're isolating that variable because why? We're looking for the answer. And so if you're trying to find what that variable or what quantity that variable represents, you can't have any other number next to it. So in this case, because we have 2X next to it, we're going to divide both sides by 2. And again, the reason we divide both sides by 2 is that we're trying to get rid of 2 on the right-hand side of our equation so that X can be isolated, X can be alone, and whatever we find on the left-hand side is what X represents. Okay, so again, we cross multiply. 150 times 5 equals 750. That's going to be on the left side of your equation. Okay, and then 2 times X is 2X. That's going to be on the right side of your equation. My right, your left, as you're looking at me probably. But you get the point, right? Wherever you decide to put that information, cross multiply, and then you're going to divide to isolate your variable. Right, you're going to divide by whatever number is next to X is what you divide both sides by. So let's say 100 was next to X, you would divide the right side by 100 and the left side by 100. If 1 million was next to X, you would just divide the right side by 1 million, the left side by 1 million, okay? So whatever number is next to X is what you want to divide both sides by, right? And dividing the right side where X is by whatever number is next to it helps you isolate X, right? Which is the goal, right? And so we divide the right-hand side by 2. 2X over 2 is X because 2 cancels 2, right? And then on the left-hand side, where we divide 750 by 2, we get 375, and that is our that is the number of miles that 5 inches represents, okay? Which is the answer to the question. All right. I think that the key thing that you should pay attention to here is that you want to make sure that you're putting the ratio in the order that is being asked of you, right? So if you had well, in this wouldn't, I'll show you an example of how that could affect your answer if you don't follow that instruction. I'll show you a clearer example as we go, as we move through the lesson. Okay, so some proportion problems ask you to find a rate. And a rate essentially just compares a quantity to one, okay? So when a rate is written in fraction form, its denominator is always one. And in word form, rates are often expressed using the word per. So when you see the word per, and again, remember I had asked you to make yourself a little dictionary as you're working on these problems to write down certain terminology. So when you see combine, sum, you know that addition is being asked of you. When you see, I'm sorry,
Product, add, product,
I'm sorry.
add, or product.
Yes, when you see product, know that multiplication isn't being asked of you. Here, when you see the word per, know immediately that you're dealing with a rate, okay? You're dealing with some sort of proportional rate. When you see per, as we saw here, know that you're dealing with a ratio that might involve a proportion, but just read the question to figure out if you're dealing with a proportion. So that's two ratios that you equate to each other, right? Because you're dealing with two ratios, or if you're just dealing with one ratio, okay? So per will always give you an indication where you should be working with ratios, okay? So here we're being told that Connie drove 276 miles on 12 gallons of gasoline. How many miles per gallon did she get on the trip? Now we're being asked for information that involves proportioning again, because we know that she drove 276 miles on 12 gallons, so that's 276 over 12. How many miles? Okay, so how many we don't know. We're going to represent that with X. Per gallon did she get on the trip? Per gallon, or you can, if you like, you can put here per 1 gallon, okay? In a different example, you might see per 5 gallons, but if you don't see a number next to the measurement, so the gallon here is the measurement, just know that the unit is 1, okay? Or the number that should go there is 1, okay? So you're gonna write your proportion out according to how the question provides information. So miles per gallon, we know that she drove 200 miles per 12 gallons, okay? And that equals to the number of miles, we don't know, so we're gonna represent that as X. She got per gallon, and again, we don't see anything, we don't see like 3, 4, or any other number between per and gallon, so we know that 1 should go there, right? And that just makes sense, right? Like if you're talking about per person, right? Nobody needs to tell you that it's 1 person, right? Like if you enter a restaurant and they tell you, oh, each plate is going to cost you $5 per person, since there's no quantity between per and person, you know that each person is going to pay $5. But if they tell you that each plate is $5 per 2 guests, then you know that for every two guests, each plate is going to cost $5, right? Or $2.50 each if you want to divide it evenly between them. So just keep that in mind, that if you don't see a number next to the measure, so in this case, the measurement is gallon. It could have been person, it could have been per inch, right? Just know that the unit, or the unit measure, the unit quantity, I should say, will be 1, okay? So we're gonna write down our proportion as 276 over 12 equals X over 1. And what are we gonna do? We're gonna cross multiply. Okay, so 276 times 1 is 276. X times 12 is 12x. And so what do? We have 276 equals 12x. What are we going to do, guys? We're going to divide both sides by 12, right? So 12x divided by 12. 12 is going to cancel out 12. You'll be left with x. 276 divided by 12 is 23. And so 23 equals x. Okay. So here might be a good example to show you what would have happened if you had inversed the order of the question, right? Let's say you had written 1 over x, right? Instead of x over 1, then you would have 276x equals 12. And then you would be dividing, because you're trying to isolate x, you would be dividing 12 by 276, excuse me. And you would get some number that's in decimal form that's not the correct answer. So when you're writing down your proportions, not only do you want to make sure that you're following the order of the question, you also want to make sure that your proportions match. So here, 276 is the number of miles. And then X on the right-hand side is also the number of miles, because remember, the question is asking us how many miles. Well, we don't know, right? 12 is the number of gallons, right? We know that she drove 276 miles on 12 gallons, right? And then that question is asking us how many miles per gallon did she get, right? So we've equated 12 gallons to 1, right? And 276 miles to X, right? So essentially you want to make sure that your numerator on the left-hand side is equal to the to whatever is being measured on the right-hand side. So let's say if this was dollars per hour, for example, right? You want to make sure that your numerator on the left-hand side is in dollars, your numerator on the right-hand side is in dollars, and you want to make sure that your denominator on the left-hand side is in hours, and your denominator on the right-hand side is in hours. Okay, so what am I trying to say? Make sure that whatever you're measuring in the numerator is the same on both sides, and that the same is true for your denominator. Okay, that way you know that you're getting the correct, you're getting the correct ratio of measurements based on whatever it is that or in other words, you're making sure that the ratio makes sense according to the expectation of the problem. Okay. So when you're working on a problem, you want to ask yourself if it can be solved using a proportion. And this may be possible when 2 quantities are compared, or when 3 values are given and you're being asked to find a 4th, right? So because there's such a similarity between ratios and proportioning, this note is just telling you, ask yourself if the question is one of proportioning, meaning do you have 2 ratios? Okay. And that will be the case if you're working with 2 quantities. So in the case of, our bottle that had the instructions on the scoops per person on the bottle, and then the number of people that you want to share it with, right? So does that involve that involves 2 separate quantities, right? The quantity that you're measuring by and the number of people that you're sharing with. Or are you comparing, right? And then you've been given like three values and you're missing one, right? So you can use your intuition here. Like, so let's say, for instance, here, where you can count the number of values you've given. You've 1, 2, you're given a per, so that's your third right there. You know that that 1 is going to go there. So your fourth is going to be that X, right? How many, right? And so here you know that you're dealing with two proportions, right? If you counted and you only saw two numbers, like we saw in one of the earlier slides with, I think it was on the batting average, right? Where we're just strictly given two numbers, then you know that you're just dealing with a simple ratio. Write down that, write out the ratio and simplify it if you have to. Or write it down in its lowest terms and you're done. Okay, so that's all this note is telling you here, that there'll be clues in the question based on how much information is given you, right? And so that's why this requires practice, because if you remember earlier in the month, I think it was the first chapter, we were working on a question that asked you how much fabric somebody needed to cover their couch, right? And they gave you information you didn't need, right? With ratios and proportions, they'll give you the exact number of information that you'll need, and you'll be able to count with how much information they've given you, whether you're dealing with a ratio or a proportion. And that's why it's important, as I was saying earlier, to pay attention to the terminology being used, right? Because if you see per, for example, you immediately know that, oh, I'm dealing with a proportion, I'm dealing with a ratio, possibly a proportion. Again, remember, a ratio is just a single fraction. I'm trying to avoid the light. A single fraction, so maybe like 1/2, and a proportion would involve two fractions that you equate to each other, right? Like 1/2 equals 3, right? So again, you would look for keywords in the question. If if the question mentions per, right, then you know immediately it's safe for you to count the number of values that you see in the question. So that would guide how you set up your answer. But if you don't see per, then that should tell you, okay, maybe there's some information in there that you don't need. This is a word problem that involves information that you possibly don't need, right? And again, that requires you getting used to how questions are asked, and also you making yourself a mental map of keywords that are used in certain kinds of questions, okay? But don't get tripped up by that, because it's a set of instructions like any other discipline. Like I was telling you, like, you know, if you want to learn how to play the guitar, when you see the C chord, it looks a certain way. It's like looks like a $sign with two things going through it. I don't know, you know, I'm not a musician, but you get the point, right? The same with mathematics. There'll be keywords, and it's a matter of you just recognizing that keyword and knowing immediately, okay, this is how I should approach this problem. But that takes practice. That takes you creating whatever is easy for you to help you recognize how questions are asked, okay? Okay, so when you're using your calculator, you can solve proportion problems in one series of calculations. So let's say that you're being asked to find the value of X in the proportion 6/16 equals 21/X. Well, what you would simply need to multiply 16 and 21 and then divide by 6. Remember, as we discussed earlier, you would cross multiply, so 16 times 21, okay? And then on the other side, oh, sorry. On the other side of your equation, you would have 6x, okay? So that's what this is telling you here. Press 16 and then the multiplication key. Enter 21. Did I say press 16? Yeah. Enter 16, multiplication key, enter 21, and then your division key, and we're dividing by 6 to get X, okay? And you would press enter, your display would read on the right-hand side of your calculator, all right? So it's a shorthand way of doing that on your calculator without having to do the steps manually. And your missing term would be 56 as it shows here. Again, more practice problems, page 690 to 695. Try to work on those. So now on to lesson 2, which covers percentages. And percent just simply means per 100 or out of 100. So for example, if you have $100 and you spend $25, you just spent 25 out of $100, or 25% of your money, right? So the key ideas to keep in mind is that the percentage symbol simply means out of 100. The 3 elements of a percentage problem are going to be the base, the part, and the rate. So again, on your little list of rules that you're making for yourself, you want to write this down, that a percentage always involves 3 parts. The base, or 3 elements, I should say, the base, the part, and the rate, and we'll discuss that in more detail, okay? And then percentage problems can be solved by writing a proportion that has a denominator out of 100. So in other words, your denominator for percentage problems will always be out of 100. Now the question is not going to tell you that, right? So you're going to, again, have to be able to recognize that the question is about percentages, and then you'll immediately know that that number is going to be out of 100, okay? So since percent is a way of showing part of a whole, it has much in common with fractions and decimals, right? So to convert a percentage to a fraction, you want to write the percentage over 100, and then you want to reduce, okay, to the lowest terms. So to convert percentages to decimals, you want to drop the percentage symbol, and then you're going to move your decimal point 2 places to the left. So for example, here, to convert 25% to a fraction, again, it's not telling you that you need to write this over 100, but because you see that percentage sign or percentage symbol, you know immediately that you're going to write 25 over 100. And then you're going to simplify that to 1/4, okay? 25 goes into 25 1 time, 25 goes into 100 4 times. You can think of this as 4 quarters, right? Like if you had 4 quarters, how many quarters do you need to get $1, right? So 25 over 100 is 1/4. Or in this case, 100 representing 100 cents, 25 representing 25 cents, right? And essentially that's where we get our terminology for quarter, right? $1/4 just simply means that we have 25 cents out of a whole dollar, right? Here we're being asked to convert a percentage to a decimal. So again, we're back to our 25%. And all you're going to do is drop the percentage symbol like it's telling you right here. And then you're going to count 2 places over to the left, right? And so you would write your answer as 0.25, okay? And you'll see why this becomes useful in examples that we'll cover down the line. In any percentage problem, there are going to be 3 elements, okay? The base, the part, and the rate. The base is the whole quantity. So you can think of your base as your denominator. And as we discussed several lessons ago, if you want to think in terms of shapes, the base would be, let's say, a circle that's divided into 3 parts with all 3 parts grayed out. So 3 would be your base number. So again, the base is the whole quantity or the amount that the problem is about. Okay, so in this example that I'm giving, our base is 3. The part, also called a percentage, is a portion of the base. So let's say we're going back to our circle and we remove one of those grayed out parts. So now we only have 2 parts that are grayed out. Those 2 portions of our base of our entire circle that are grayed out are the parts, right? And then the rate is a number that's followed by the percentage symbol. So in the case of our example here, 2/3 would equal 66%, right? So we could say another way of representing that circle is that 66% of it is grayed out, okay? Again, in any problem that's involving percentages, you'll have 3 parts. You'll have your base, okay, which is the whole thing, or the whole quantity, I should say. You'll have your part, okay, which is a portion of the whole, and then you'll have the percentage. Let's say we went back to our example of quarters, okay, and let's say you had 4 quarters on a table. Those 4 quarters are your whole, right? And then let's say you decided to give your friend 1/4, right? And you're being asked, well, how many quarters are you left with? Well, you're now left with 3 parts of that whole, right? That whole being 4 quarters that you had initially. You're now left with 3 parts. So 3/4, or 3/4, is your fraction. And then that's equal to 0.75, okay, or 75%, or 75 cents, right? So in this example, we're being told that at a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, the part, and the rate in this situation. So you're looking at this problem, we're seeing that we're given 3 numbers, right? And all of those numbers are relevant to the question, okay? 15%, right? Remember we said that per earlier is our indication that we're possibly dealing with a proportion, right? So here, 15%, we also said that when you see this percentage sign, and write it 2 different ways, either as what, 15/100, or you drop the percentage sign and you count 2 decimal places to the left, and you can write it as 0.15, okay? So the entire bill of $20 is the base, okay? The $3 is part of the base. Remember, we explained, if you think in terms of circles that we had explained earlier, we have 2 grayed out circles. Excuse me, we have 2 grayed out portions out of 3 parts that are grayed out. In this case, we're tipping $3 out of a $20 bill, right? So that $3 is part, that $3 is part of that $20. That $3 is coming out of $20. Think of it that way. Okay, so the $3 tip is part of the base, which is 20, and then the rate is 15%. They're telling you in advance that if you give this waiter $3, you're essentially giving her a 15% tip. Okay, so well, let me show you in the next slide. You would pretty much write out your solution in terms of a part and the base, right? So again, $3 is the part, right? Or you can think of it as that $3 is coming out of the $20, which is your base, your whole thing. Like that $20 bill is all you have in your wallet. Okay, so that's your base, and your tip is going to come out of that base. Your $3 is going to come out of that $20, right? So you can write that in terms of a ratio 3 to 20, 3 over 20. And then you're equating that to the tip, which is 15%. And again, they're not telling you in the problem that you need to write the 15 over 100, excuse me, but because you see that percentage sign, you immediately know that 15% can be written as 15 over 100. And you're equating that to the tip that's coming out of the base. So in this scenario, we're going to cross multiply. 20 times 15 is 300. 3 times 100 is 300. So we know that we have equal, we know that the ratios are equal. And so this is an example of what I was trying to show you earlier, that cross multiplication, you're essentially equating two quantities that are the same. And in this scenario, it's clear because this 15% should match the number that you're taking out of that $20. Like on this right-hand side, for example, and we'll see later on sometimes percentages that are greater than 1, you shouldn't have 200% here, right? So this shouldn't be equating to $50, right? Because we only have a $20 bill. So this percentage on the right-hand side should match the proportion reflected by the tip that you're given or that you're giving out. So you're giving out just $3 out of that $20 base, and this 15% represents the rate, right? Or in percentage form, what that $3 means. That $3 coming out of this $20 base, this rate represents what that $3 means in percentage form, okay? And that's why we see an equal sign here, right? This is basically telling you that if you didn't want to talk to maybe your friend, like if you didn't want to tell your friend that you gave a $3 tip, you could easily say, oh, I gave a 15% tip. And that's you're saying the same thing. You're basically telling your friend who's a mathematician, they would immediately understand that, oh, you gave the waiter $3, okay? And that's all this is telling you, right? Is that you're, again, these are two different ratios that you've equated to each other, and this entire thing is called a proportion. Okay, so remember that a proportion always reflects two ratios, and those two ratios are the exact same thing, but written in different forms, okay, or written in different ways. So again, instead of you telling your friend, oh, I gave the waiter a $3 tip, you would tell your friend, oh, I gave the waiter a 15% tip, and that means the same thing as you gave the waiter a $3 tip. Or if you told your friend, I gave the waiter 15% tip, you're essentially saying you gave the waiter $3, okay? So I hope that that's clear. If you have any questions, do let me know. So on the test, the word of will often come before the base in a percentage problem, right? So you gave the waiter $3 of your $20, right? So for example, if you're asked to find 75% of 250, you know that 250 is the base, okay? So you can solve percentage problems by setting up a proportion and then solving for the missing elements. Just remember to express the percentage as a number over 100, right? So at a plant that manufactures lighting fixtures, it's expected that about 2% of the fixtures assembled each day will have some type of defect, right? So if 900 fixtures are completed in one day, how many are expected to be defective? Well, we're going to go back to our formula. We know that the part over the base equals the rate over 100, okay? Again, and if it helps you, you can think of this in terms of tipping, because I think that that's something that we're used to, that we do all the time. You go to a restaurant, you leave a tip, right? So the part, you can think of the part as your tip. The base, you can think of how much the total cost of the food, and then that's equal to the rate, right? So if you tipped 10%, that's the rate. If you tipped 10% of, let's say the base was $100 and you gave $10, right? That's 10%, right? Or that's the same as saying that you left $100 bill, and out of that $100 bill, $10 went towards the tip, okay? So again, when you're dealing with your percentages, your formula is always going to be your part over your base, and you equate that to the rate over 100, okay? So in the question, we don't know what the part is, right? Because again, we're just told that a plant manufactures lighting fixtures, and it's expected that about 2%, so we have our rate, 2 out of 100, that's on the right-hand side, right? So we have our rate already. About 2% of the fixtures are assembled each day will have some type of defect, right? If 900 fixtures are completed, so we know that 900 fixtures are completed, that's our base, right? In one day, how many are expected to be defective? It's asking you for a part, right? Because we know that of those 900 fixtures, a part of them, every single day, you're making 900 fixtures, okay? And every single day out of that 900, a part are going to be defective, but we don't know how many, right? So since we don't know how many, that means that part is our variable that we're going to represent as X, okay? So you're going to write down your formula to represent the information in the problem. So X is the number of parts that will be defective. We don't know how many. So since we don't know how many, we're going to represent it as X. And our base is 900, right? That's the number of parts that we produce every day. And we're told that the rate is 2%, right? So that tells us that's 2 over 100. So what do? We cross multiply. 900 times 2 is equal to 100 times X, or X times 100, same thing, right? So because when you're multiplying, the order doesn't matter. 900 times 2 is the same thing as 2 times 900, right? I'm just saying that the order that you write it in doesn't matter, okay? So you're going to write down your equation as 1800, 900 times 2 is equal to 100x, okay? And what do we do to find x? We isolate it. And how do we isolate it? We divide both sides by 100, right? So 100 divided by 100 is going to leave you with x on your right-hand side because 100 cancels 100. And then on your left-hand side, 1800 divided by 100 is 18, right? And so that's our x equals 18. We know that the company can expect that for every 900 parts that it makes, 18 will be defective. Okay. So let's walk through the logic in this question again so that you can see how you should be maybe approaching the question to get clues from it, okay? So again, the question is telling you that at a plant that manufactures lighting fixtures, it's expected that about 2% of the fixtures assembled each day will have some type of defect, okay? So immediately when you see 2%, you know that you're dealing with a rate because percentage always represents a rate, right? And you know that there's a possibility that this is a proportion question, but we're not sure yet because we haven't finished reading the question, but immediately we're giving information about a rate, right? So you're gonna write down your rate, write down rate equals 2%, which equals 2 over 100, okay? Then you keep on reading. If 900 fixtures are completed, so when you see the word completion, right, that tells, or when you see the word completed, that tells you that that's the entirety of something, right? And that gives you indication that that's a number representing a base, because a base, again, is the whole of something, right? So you can think of, if you wanted to represent your fixtures in terms of a circle, you could think of it as a circle with divided into 900 parts. All 900 parts are grayed out, okay? So let's say each time one fixture is completed, you shade in one part of your circle gray. The second part is completed, and this is done 900 times, right? So they're telling you if 900 fixtures are completed, so you know, aha, base equals 900, okay? In one day, how many? So how many is indication of a portion or a part, right? How many are expected to be defective? Well, you can write down how many equals part, which equals X, because we don't know, right? And so you can look at the information that you've written down. You know that you've written down your rate, which is 2% or 2 over 100. You know that you've written down your base, which is 900. And we don't know X. So we're dealing with a proportion, right? And you just proceed to set out your solution to reflect the formula for percentage, which is part over base equals rate over 100, right? So we know that the base is 900. We know that the rate is 2%, which is 2 over 100. We don't know the part, right? So we would just simply write that down as X. And now we can proceed, because what do we do when we see X on one side of our equation, either on this side or the other? We cross multiply and then we isolate, right? So you would cross multiply 900 times 2 is 1800, 100 times x is 100x. And then you isolate x by dividing both sides by 100. Okay, 100 divided by 100 cancels each other out. You're left with x. You successfully isolated x. And then you have 1800 divided by 100 on the other side of that equation. 1800 divided by 100 is 18. And now we found out the value of x, right? So that would be the same as writing 18 over 900 equals 2 over 100. Excuse me. And if you cross multiply it to make sure that you found the right x, 18 times 100 is 1800. 2 times 900 is 1800. So because you have 1800 on both sides, you know that your answer here for x is correct. Okay, so that's one way that you can check your answer when you're done, is to just plug back, because you're basically saying to in response to the question that, well, x equals 18, right? And so you can go back to your formula. Since you said that x equals 18, you can write 18 here. And then remember what we did in previous steps. We cross multiply to check that our proportion is the same, right? So again, when you see an equal sign, what you're saying is that the quantity, no matter what it is on the left-hand side, is equal to whatever is on the right-hand side. And how do we check that? We cross multiply. And if you multiply across both sides and you get the same number twice, then you know that that proportion is correct. So when we've plugged back 18 into a formula just to check our answer, we multiply 18 by 100, we know that that's 1800. We multiply 900 by 2, we know that that's 1800. And so now you have confidence that your answer X is correct, right? And then you can confidently say that 18 of the 900 fixtures will be defective. So when you get home, you can tell your friend, oh, today we at the plant, we completed 900 fixtures and 18 of those fixtures were defective. And your friend, that's the mathematician, would recognize, oh, that's 2%. Or you can tell your friend 2% of 900 fixtures were defective, and your friend would know that that's 18 fixtures. Okay, so again, we're representing exactly the same number. Anytime you see an equal sign, that's telling you that what's on this side is exactly equal to what's on this side. What's on the left side, I should say, is exactly equal to whatever is on the right-hand side. Okay. Yeah, so there's practice questions. Make sure that you work on those just to get accustomed to how the questions are presented, because there'll be different styles of presenting the same type of information. But the more that you read, or the more that you see that and you make notes for yourself, the easier it'll become for you to recognize. It's just like learning a language, right? So as we've discussed many times before, English teacher will tell you directly, mathematicians use coded language, right? So what do you do when you're learning English? First, you start by learning ABCs. Then with the ABCs, you start memorizing how words are spelled. And once you have memorized how words are spelled, then you can put those words together in different sentences that would mean the same thing. So my name is Sally and her name is Sally are two ways of telling you that we're talking about an individual named Sally, right? But they're written in different ways. So it's the same thing with math, right? You'll see a problem that requires proportions, but they'll write it in different ways. But as long as you can recognize the coding, or as long as you can recognize the ABCs, then you'll recognize, aha, this is a percentage problem. I'm not going to approach it as a decimal problem. I'm not going to approach it as a multiple, percentages of sometimes will give you an answer that's in decimal form, but you get what I'm saying, right? Like you need to understand how to approach the problem. And you do that by getting used to how mathematicians represent or the vocabulary that mathematicians use, okay? And you get comfortable with that representation, the more that you work on practice problems, okay? So again, consider practice problem your friend because they're giving you breadcrumbs or clues as to what you need to recognize when you're answering problems on your test, okay? And then don't forget, again, to make yourself a list of those coded words, right? So that you know what you're dealing with. All right, so here the lesson 3 covers solving for part. So again, we're back to our percentage formula. And this time, because we're solving for a part, we're not writing it like this, which is the original form, right? We're changing the subject to a part. So that means that, you know, the same thing that we did anytime, whenever you saw X and you want to isolate it, you would multiply both sides by the same quantity. And then the numbers that are equal will cancel each other out. And then you would be left with X on one side and a ratio that represents what X actually is on the other side, right? And then you can simplify. So the same thing applies here. We're looking for parts, right? So what are we gonna do? Multiply both sides of our equation by the base, right? Because we're trying to isolate the part. So you would multiply the left-hand side by the base. So you would just write out the same denominator. So in this case, because we don't know what it is, we're just going to write out base here, right? So the base would cancel out the base on this side, and that would mean that we're left with the part, and that that then translates into part equals the rate times the base, right? So it's the same formula, but all we've done is change the subject to the part. And when I say subject, I mean the quantity that we're interested in, right? In the past, our subject was X. Right now, the subject that we're interested in is the part, right? So you can see here that now part is the subject, and to find the part, you would simply multiply the base times the rate. But I just wanted you to recognize that this formula is coming from the same formula that represents a percentage, but all we've done is change the subject to part, okay? To change a percentage to a decimal, you would follow the same rules. You would drop the percentage sign and move the decimal point 2 places to the left. And then to change a decimal to a percentage, you would simply move the decimal point 2 places to the right, and then you would add the percentage sign. Okay, so if you can imagine 1/2, its decimal equivalent is 0.5, right? So to change 0.5 to a percentage, you would move the decimal point 2 places to the right, right? So since there's no value after 5, you would insert a 0, as we've learned in previous lessons. And your percentage representation is now 50%, right? And we know that 1/2 equals 50%. And to change that 50% back to decimal point, you would just drop the percentage sign and then move your decimal point 2 places over to the left, okay? And that would equal 0.50 or 0.5. And again, as we discussed earlier, dropping that 0 doesn't affect the value of 0.5 because you recognize that that 0 is acting as a placeholder in this particular case or in this particular scenario or for that particular decimal. You've seen how to use proportions to solve percentage problems, right? So you can also solve percentage problems using the formula base times rate is equal to the part. And you can write out this little diagram to help you recognize or remember that, okay? Example, B here represents base, R represents the rate, and P represents the part. So if you're need to solve for the part or something, well, you would just cover a part, and what are you left with? Base times rate, okay? If the question is asking you to solve for a rate, what do? You just cover up R, and what are you left with? P divided by B. Notice the operations here, right? So when you're going across, you should respect whatever operation is there, right? We're going across, there's a multiplication sign. So if P is covered, you know that you're going to multiply the base times the R, or the base times the rate. If R is covered, you know that you're going to divide the part by the base. If the base is covered, you know that you're going to divide the part by the rate, okay? So pay attention to the direction of your operations, and also whatever operational symbol is represented in between your elements, okay? In this case, your elements are the part, base, and the rate. So pay attention to whatever operational symbol is shown in between the elements. And just keep in mind that this is a really good way for you to remember the order of your formula, if you will. So a company offers its employees 2 health plans. In a recent newsletter, the personnel department stated that 70% of the employees choose Plan A. If the company has 320 workers, how many choose Plan A? Well, that's a question about part, right? Because we know that 320 is the total number of workers, and we're given a percentage, right? And how do we know that 320 is the total number of workers? Well, it simply tells us, right, that the company has 320 workers, right?
The whole part.
I'm sorry?
The whole part.
Yes, exactly. And then here, how many, remember again, on your little on your little code sheet or whatever you want to call it, you've written down that how many, every time you see how many, that's immediately telling you that you're working with some sort of variable you don't know, right? So you can represent it as X, right?
Okay.
And X always represents a part of something, right? So in this case, well, sometimes X can represent the base, but you want to read carefully, right? Here we know that 320 is all the workers. So therefore X must be the part, right? If it told you that only 15 of the total number of workers, then you would know that X represents, it tells you of the total. Well, we don't know what the total is. So in that scenario, X would be the base, right? But in this particular scenario, we know that X represents the part, okay? So we're told that the rate is 70% and the base is 320, the total number, which is the total number of workers. So you would need to solve for the part. So using your diagram, you just want to gray out or cover the part of your diagram that represents P, okay? And then you can see that you need to multiply to solve the problem. You need to multiply the base times the rate, right? And we've discussed how to change a rate to a decimal, right? When you see 70%, that represents 70 over 100. And another way of writing that is that you drop the percentage sign and then you move your decimal 2 places over to the left. So 1, 2, your decimal point would be here, and 70%, you can now write it as 0.70, right? So since the diagram is telling us that the way to find part, which we've covered up, is base times the rate, you would just multiply the information that we have about the base, which is 320, times the rate, which in this case is 70%, which we've rewritten as 0.7, right? So we're basically multiplying 320 by 70% or by 0.7, 0.70 or 0.7, and you would just simply enter that into your calculator and your answer would be 224. Okay. And then if you wanted to check your answer, you would write, because you said that X is your part, right? 224 over 320 should equal what? 70 over 100. Okay. And then you just cross multiply and you should get the same quantity, right? Okay. And you know that you found the right answer because both of your quantities are the same. Not 2,240, 22,400. Anytime you're multiplying a quantity by 100, you just want to add 2 zeros, right? So if we add 2 zeros after 224, we'll get 22,400. So when you cross multiply, 320 times 70 should give you 22,400, and then 224 times 100 will give you 22,400, and you know that you have the correct proportion on both sides. 224 over 320 equals 70 over 100, or 70%, okay? So this is telling you that when you take the reasoning test, just make a quick sketch of the percentage diagram to help you analyze the percentage problems. This is the percentage diagram. We know that P goes on top here. We know that on the border, on the 2 lines here, we have your division symbol, and then in between your base and your rate, we have the multiplication symbol. And then you just cover whatever proportion it is that you're looking for, and then pay attention to the operation sign, right? So again, here on the bottom is multiplication, and right above on both sides is division. So this portion of the lesson goes over solving for a rate. And again, you simply just rewrite the percentage formula to solve for a rate, and you would just use, you would write out the formula to reflect part, divided by base equals rate, as we've seen earlier. And again, you can see that that's reflected in the formula, because since we're looking for the rate, you just cross that out. And what are you left with? Part. And you can see that the operation here between part and base is division. So that simply just tells you that to find the rate, all you do is divide the part by the base. So in this example, we're being told that a computer system is regularly priced at $1,600. On Friday, the manager reduced the price by $640. And then the question is asking you by what percentage that the manager discount the computer system, right? So look at the question again and see, okay, well, you know that the question is asking you for a percentage. So immediately you know that we're dealing with a proportion, right? And so on the right-hand side of your equation, we're gonna have some quantity over 100 that's representing our rate, right? Because it's asking you by what percent did the manager discount the system, okay? We know that our base is 1,600, which is the regular price. And we know that he reduced this 1,600 by a portion or a part of that 1,600, and that part happens to be 640, right? Excuse me. So what do? You're gonna state your solution in terms of the information given. The base is 1,600, which is the regular price, and the part is 640, or the amount that the price was reduced by, right? And so you're being asked to find the rate of the discount. So you're gonna cover R, of which represents the rate, or some number over 100, right? Because remember, we discussed earlier, a rate is always going to be in terms of a percentage. It's going to be some number over 100. So when you see rate or you see percent, know that those two words are interchangeable, okay? And now you need to divide the part, which we know is 640, by the base, which we know is 600. We set up our problem in terms of long division, or you can use your calculator. In this case, you're going to write 1,600, your division symbol, you're going to put 640 as your dividend. 1,600 doesn't go into 6, so we have nothing there. 1,600 doesn't go into 64, so we have nothing there. 1,600 doesn't go into 640 either, so we represent that with 0. You want to place your decimal point exactly in the same position as in your dividend, okay? 1,600 into 6,400, 4 times, it goes 4 times. 1,600 times 4 is 640. You subtract 640 from 640, you're left with 0. And so you know that your answer is 0.4, which we can represent as a percentage when we move our decimal point 2 places over to the right. Okay, so 0.04 is the same as 40 over 100, which should be, which is the same as 40%, right? So this should show there should be a 100 per 100 over 100 here, right? Because remember, when you see a decimal that doesn't have a whole number before the decimal place, it represents a quantity less than 1. Remember, we talked about that, I think it was in chapter 2. So you can think of this as 40 cents, okay? Anytime that you see a number or a decimal where the number before the decimal point is 0, The easiest way to visualize that quantity is in terms of dollars and cents, right? So this 0.4 essentially represents 40 cents. If you saw 0.44 here, that represents 44 cents. If you saw 0.448, what would we do? Since the number on the right of, let me use a different number so to make it clear. Let's say we saw 0.438, right? Since the number on the right of 3 is 8, and it's greater, 8 is greater than 5, we would round up, right? So you would round 0.438 up to 0.44, and you would say you had around an estimate of 44 cents, okay? So anytime you see a number, or excuse me, a decimal that starts with 0, indicating that there's no whole number before it, immediately just think of it in terms of dollars and cents, okay? And it'll be easier for you to visualize what's going on, right? So essentially here we're saying that we have 40% of 1, okay, or 40 cents, or 40 over 100. Okay, which is what 40 cents means, right? If the cents there, cent is a French, derives from a French word, centime, right? Meaning 100. So just think of that as 40 cents then means 40 over 100. 2 cents means that you have 2 cents out of 100, out of 100 cents. Right, or 2 pennies. So if you had 1.4, right, that means that you have $1.40, right? So 1 whole and 40 cents. So essentially, you can write down your answer, or you can state that the manager discounted 1,600 by 40%, okay, or 40% of the base, which is 640, okay? Or you could rewrite it as 640 over 1,600 equals 40 over 100. And when you cross multiply, you should get the same number. So 640 times 100 gives you, just add 2 zeros here, 64,000. So if you cross multiplied 1,600 by 40, you should also get 64,000. And then you know that your proportions are the same, right? Which makes sense, because if the price of the whatever it is that the manager is selling is discounted by 40%, it means that 640 is coming out of that total quantity, right? And so they should be the same, right? That makes sense logically. Both sides of the quantity on both sides of that equal sign should be the same, okay? So you always want to ask yourself whether your answer seems reasonable. Okay, so for example, you know that 40% is a little bit less than 1/2, right? And 1/2 of 1,600 is around 800. So since we said in our answer that 40%, this 640 represents 40%. Well, 40% is less than 50%, right? So whatever this quantity represents, which in this case is 640, should be less than whatever 50% of 1,600 is. And 50% of 1,600 is 800, and 640 is less than 800. So our answer makes sense, right? And that's all this is telling you here. This portion is telling you, always ask yourself whether your answer seems reasonable. And in this particular example, you know that 40% is a little bit less than 1/2, and 1/2 of 1600 is 800, right? So since 640 is less than 800, you know that your answer is reasonable, or your answer makes sense. Okay. Do you guys have any questions?
No.
Okay. Practice questions starting on page 704. Make every effort to work on those as much as you can. So this portion of the lesson then focuses on solving for the base. Some problems on the reasoning test may require you to solve for the base in a percentage situation. So always remember that the base represents the whole, okay, or the entirety of a particular item. So read each situation carefully to figure out what element is missing, and then you're going to choose the correct method for solving the problem, okay? So in this example, we're being told that 75 in a math class, 75% of the students got at least a B grade on the final exam. If 18 students got at least a B, how many students are in the class? So here, you want to look at the question for clues, right? It's telling you that if 18 students, so that already tells you that 18 is a part, it's not the whole, right? It's not the base. If 18 students got at least a B, how many students are in the class? And then here's your other indication. How many students are in the class is a question about the base, right? It's asking
The whole part.
exactly. So you're gonna look at your little diagram. We have our rate, which again, if you remember, your rate is always written as a percentage, right? And in this case, our rate is 75%. Okay. Sometimes the rate can be given to you as a decimal, right? So if you saw here 0.75, we've already discussed that we could, to write down or to represent 75% as a decimal, we would simply drop the percentage symbol, and we would move the decimal point, because there's an imaginary decimal point here. So another way of writing this is 75.0%, right? So since we know that 75.0 and 75 is essentially the same quantity, no one bothers writing the 0.0, right? Or the 0.00, right? Like if you saw on your receipt, let's say you ordered a pizza and you saw that the tip was 15%, you know automatically that that indicates 15.000%. 0 continues into eternity, right? For that particular decimal, but nobody writes down all those zeros. It's just simply written as 15%, right? The same, anytime you see a whole number expressed as a percentage, know immediately that there's a fixed decimal point right after the last digit. So in this case, the last digit is 5, right? So we could express this rate by dropping the percentage symbol and moving our decimal point that's fixed here 2 places over to the left. So if this example had said in a math class 0.75 of the students got at least a B grade, you know that that's a rate that you can represent as 75%, right? So we have information about the rate, and we have information about only a portion of the students, right? So that's our part. So you would just cross out your B here, which represents the base, which is what we're looking for. And you know that your formula is going to be your part divided by your rate. Okay. So you write down your long division. We already know that 75%, I mean, you're not going to write 75 over 100 right here, right? Because that would just make your work a lot more difficult. You want to rewrite 75% in terms of its decimal equivalent, which is 0.75, okay? And then inside your division symbol, you're going to put your dividend or your part, which is 18. And as we discussed, when you're dividing decimals, you always want to move your divisor, which in this case is the rate, 2 decimal places over to the right. And then you want to do exactly the same thing with your dividend, right? So you're going to move, after you've changed your rate to a decimal point, excuse me, to a decimal value, you're going to move that decimal point 2 places over to the right. And then you're going to do exactly the same thing with your dividend. You're going to move exactly 2 places over to the right. Okay. Don't move the your decimal point more places than is present in the divisor. Okay, so then you would just continue, you would place your decimal point right above your dividend in the exact same location where you've moved it over. And then you would continue with your division, your long division. So 75 does not go into 1. So there's nothing there. 75 doesn't go into 18. There's nothing there. But 75 does go into 180 twice. Okay. 75 times 2 is 150. You're going to draw your line. 75 goes into 300 4 times. 75 times 4 is 300. And so we're done with our long division. And we know that's, or we can say that 0.75% of 18 is 24. Okay. Or you can just use your calculator. And you would just simply divide 18 by 0.75. Okay. Do you guys have any questions, or do you want me to repeat anything in this portion of this example?
No, I'm good.
Okay. All right, so most of the time when we work with percentages that are less than 100, or most of the time we work with percentages that are less than 100, right? But when a percent is greater than 100, we know that the part is greater than 1. Okay, so as I was telling you earlier, the example I think we were looking at was 0.4, and I asked you to imagine 0.4 written as 40 over 100 or 40 cents. But if you had a 1 in front of that 0.4, basically the author is telling you that you have $1.40, and you know that 1.4 is a quantity greater than 1, right? So again, anytime you see a decimal with that starts with a 0 on the left side of the decimal point, or that doesn't have a whole number on the left side of the decimal point. So again, something like 0.4, know that that quantity obviously is less than 1, right? Because we immediately understand that 0.4 can be written as 40 over 100, or you can think of that as 40 cents, right? But if you saw 1.4, you know that that quantity is greater than 1. and 1.4 can be thought of as $1.40. So again, remember that decimals deal with a portion of a whole, right? It's not the whole number in its entirety, it's a portion of that whole number. So when you see a whole number, like let's say you see just 1 written on its own, you know that there's no portion after the decimal point. That's always there, even though it's not reflected. There's nothing after the decimal point, meaning that you're dealing with a whole number. But when you see 1.4, that 0.4, anything after the decimal point represents a portion of that whole number that you're dealing with, right? So in the case that you would see a 0.4, that's telling you that you're dealing with a quantity that's less than 1 because there's nothing before the decimal point, okay? So that's essentially what this is trying to tell you, is that if you see, in the event that you see a percentage that with a part that's greater than the base, then you know that the percentage is going to be greater than 100. So let's say the part was 50 over 25, you know that your percentage will be greater than, you know that your rate or your percent will be greater than 100, okay? I hope that's clear, but it should be clearer with the examples that follow. So the workforce at Eastland Inc. is growing very rapidly, and the number of employees this year is 225% of the number last year. If there are 135 employees this year, how many employees did the company have last year? So here, we already see that we have a percentage that's greater than 100. If there are 135 employees this year, how many employees did the company have last year? This how many tells you, number one, that we don't know, it's the variable. But also we're dealing, this is the base, right? Because from the way that the question is written, we know that this 135 is a part of a larger group of employees, but we don't know the number, right, of that whole. Okay, so we have our part, which is 135. We have our rate, which is 225%. And we're looking for the base. So we're going to cover the base. And then we're going to write our equation as B equals P over R, or P divided by R, right? So again, our part is 135 and the rate is 225%. And that's always going to be easy because, I mean, to recognize that rate will always be easy because you'll see either a percentage point or you'll see this represented in decimal form. So this would, to represent 225 in decimal point, we drop the percentage sign and we move the decimal point that's always going to be after the last digit. We move the decimal point over to the left twice, only twice, guys, right? Because if you remember our number line, the hundreds place is always that second digit. If you imagine 0, right? We have our tens place, and then we have our hundreds place. And remember, we discussed that for every 0 that you add, we get richer, right? So we've got going from 10. If we add 0, we move over 1 place to the left, we have 100. If we add 0, we move over to the left, we have 1,000, right? So, and again, I explained earlier today that when you see this percent, Per is always an indication of division, and then cent just means 100, right? So 22%, excuse me, 225% can be rewritten as 225 over 100, or you drop the percentage symbol and you move your decimal place 2 places over to the left, and that would be written as 2.25. Okay, so we have our rate, which is 225%, or 225 over 100, or 2.25. Okay, and then you would just solve based on the information you have, and all we're doing here, based on our formula diagram, is we're dividing 135 by 225%. So yeah, as was discussed, you want to rewrite 225 to its decimal equivalent, and to do that, you would drop the decimal, excuse me, the percentage sign, and then you would move your decimal point 2 places over to the left, and then you divide 2.25 by 135. So you write out your long division, and again, you start by moving, because the reason when you're doing your long division, the reason you're moving the decimal place over to the right is because you're trying to figure out where the decimal place should go in your answer, right? So 135 is a whole number. So first, you always want to start by moving the decimal place in your divisor, which in this case is 2.25. So you move the decimal place over only 2 places, because again, the goal is to make your divisor a whole number. And you only move the same number of decimal places that you've moved in your divisor in your dividend. So since we're moving 2 places over to the right in the divisor, we're also going to move 2 places over to the right in the dividend. Okay. So in our dividend, we move 2 places over to the right. We place our decimal point exactly right here. And then we continue with our long division. Okay, we know that 225 doesn't go into 1. 225 doesn't go into 13. 225 doesn't go into 135. But 225 does go into 1,350. Okay, so notice that we're continuing to move 1 place over to the right until we have a whole number in our dividend that's divisible by our divisor. Okay, so if you remember when we were talking about decimals, the rule was to move your decimal point the same number of decimal places as you have in your divisor, you move that same number of decimal places in your dividend, and then you continue as like you were dividing a whole number. Okay, so that's why we're now talking about 202.25 as 225, right? Because we've moved the relevant number of decimal places to let us know where our decimal point should be. And then we're just continuing as like we're working on as we're working on dividing whole numbers. Okay, so 225 goes into 1,350 6 times. And again, immediately once you get your partial division, and again, partial division means we're not done with our division, we have a small portion. we've worked on a small portion of our dividend. So 225 times 6 gives you 1,350. 1,350 minus 1,350 is 0. If you remember one of the notes that was in chapter 2, dividing by a decimal that is greater than 1. Remember we said that 225 percent, because the portion is greater than the base, we know that that percentage or that rate is greater than 1. And when you're dividing by a portion or by a decimal, in this case 2.25, that's greater than 1, your answer should be smaller than the quantity that you're dividing by. Okay. If it helps you, you can think of this as $2.25, and then you have $135, and then you ask yourself, how many people, if you decided to give that $135 away, and you only wanted to give $2.25 at a time, how many people would get 225 cents from 135? Well, you know that it'll be a sizable number, right? But that number shouldn't be greater than 135, right? It shouldn't be greater than 135 because you're dividing by a quantity that's greater than 1. So if you were dividing by 1, for example, like let's say you wanted to give the entire quantity away, right? You would divide by exactly 135, and you would only be able to give 135 to one person, okay? But because you're dividing by a quantity that's greater than 1, in this case, $2.25, you can give this amount to more people, but the number of people that you're giving this amount to is going to be less than 135. At the end of the day, what you should recognize is that when you see a percentage that is greater than 100, okay, like this, for example, 200, where the number over 100 is greater than 100, so 225 in this case, know that it's the rate is greater than 1. So again, back to our example where we're trying to give away $135, and you've decided that you only want to give away $2.25. This is just telling you that only 60, you would be able to give away $2.25 exactly 60 times, okay? And you can check that by multiplying 60 by $2.25, and that would give you exactly 135, which is the amount that you started with, okay? So when you're looking at your long division and you've completed your steps, you can check yourself by looking at your answer. Let's use a smaller number, if that will help. Let's say that you have $1, okay, and you decided that you want to give away 25 cents, okay, and you're trying to figure out, well, how many people can I give 25 cents to, right? In that particular scenario, because 25 cents is less than 1, or 0.25 is less than 1, your answer should be greater than your dividend, which is 1, right? So you should be able to give 25 cents to exactly 4 people, right? Because in that particular scenario, 25 cents is less than 1, So you know that your answer should be greater than 1 or greater than the quantity that you're dividing by, right? But let's say that you were trying to give 75 cents of that $1 away, right? And you're trying to figure out how many people can get 75 cents from $1. Again, you know that 75 cents, you can only give that away to one person. You can only give 75 cents from $1 to one person. So again, this number here should not be greater than 1. Okay, so in this particular example, because this number 2.25 is greater than 1, right? It's not 0.25, for example, it's 2.25. So you know that this quantity will be less than whatever your dividend is. Why? Because you're dividing a number that's greater than 1, right, into this whole number, and whatever you're left with shouldn't be greater than what you started with, right? So you shouldn't be able to give $2.25 to more than $135, to more than 135 people, okay? Because in real life, that wouldn't make sense, right? You wouldn't be able to do that. So that's all in terms of when you're looking to check your answer, you should think of it in terms of those two examples. If you have a number here that's less than 1, meaning that your decimal starts with a 0 point whatever, that portion, that quantity is less than 1, you know that whatever you divide by, you divide that quantity by, will be greater than your dividend. So in our example, we used 0.25 divided by 1. We know that the answer will be 4. We'll be able to give 25 cents away to 4 people, okay? But in this case, when your divisor is greater than 1, so in this example, 2.25, you know that your answer here should be less than your dividend. And that makes sense if you're thinking in terms, again, of dollars. You want to give $2.25 away, and so the total amount that you have is $135. You know that you won't be able to give away more than what you have, essentially. You're not going to be able to give this number, you're not going to be able to give $2.25 to more than 135 people, right? Because mathematically, that's not possible. You should, the maximum number of people that would get $202.25 is 60, okay? So it's a very long-winded way of saying when you're checking your answers, if the proportion is greater than 1, this number should be smaller than whatever's here. And if this divisor is less than 1, this number should be greater than whatever is here. Okay. Do you guys have any questions?
No, it's okay.
Okay. So don't begin calculations before you completely analyze a situation. Make sure that every percentage problem has 3 elements, as we discussed earlier: a base, a proportion, and a rate. And then make sure that you know which one is missing before you multiply or divide. And again, in terms of looking at our formula, if you're missing the base, you're going to divide the part by the rate. If you're missing the rate, you're going to divide the part by the base. And if you're missing the part, you're going to multiply the base by the rate. Exactly. again, practice exercises starting on page 710 to 712. Make sure that you're working on these and try not to leave them to the last minute because you need to pace yourself. Give yourself time to absorb the information and work through the problems.
Can we upload them step by step?
I'm sorry?
Can we upload the exercises step by step?
You mean
For example, we make the first, for example, the page you just showed up.
yeah.
We make this one, we upload it, and then another day we make the others, we upload them.
If that will be easier for you, but I would suggest maybe just working on them and keeping track, you know, and then once you're done, upload everything.
Yeah,
at the
upload
same
that.
time.
Okay. Okay.
Yeah, I think it'll be because then you can track, you know, once you're done, you
Mhm.
can count the number of solutions you have. It should be 39 as I explained in the
Okay.
at least for the first one, for the first quiz assignment, it should be 39.
Okay.
And you know, I think it would be best to, I don't want to assign homework and quizzes separately because I don't want to ask questions that won't be asked on the GED. So I'm following the what do you call it, the model of the book, and the Kaplan review is pretty good in terms of like so my younger brother is an attorney, for example, and he followed the review and he was able to pass his exam because the questions were pretty similar to what's in the book, right? So it would be a waste of time for me to assign you homework from the book, you know, from after each lesson,
Yeah.
then try to find questions, different questions.
Okay.
Yeah.
Yeah.
So that's why I think it's a better idea for you guys just to work on the practice questions on your own and then turn in a portion of those as your quiz, because that's the same information or the same kind of information that you're going to see on your exam, right? How did I start talking about that?
It's okay.
I forgot what I was trying to make a point, but I forgot.
No, about I said if I can upload it step by step.
Oh yeah. So it would be easier for you to pace yourself or to keep track of what you're doing by just uploading everything once you're done.
Okay, good.
You know what I mean? Yeah. All right, so this portion of the lesson talks about, it basically just looks at how to use your calculator to find or to work with the percentage formula. So by changing percent to either a fraction or a decimal, you can use your calculator to solve problems. And I don't know if you remember, but earlier in the lesson, I was talking about how when you see a percentage, let's say 75%, you know immediately that that means 0.75, and that becomes useful when you're using your calculator, which is what this note is telling you here. So one way to solve percentage problems on your calculator is simply to just change the percentage to a decimal or a fraction. And on the TI 30X multi-view calculator, you can use the percentage and then the second function key to find the part and the base. And you'll see that as we work through this portion of the lesson. So to create a percentage, you would simply use the second function. To create a percent, excuse me, you would use the second function and then press the percent key, which is in green over the left parentheses key. So In this example, you're being asked to find 25% of 120. And you're told to try to use your calculator to find both the decimal and the fractional equivalent. And remember, we talked about fractions as being equivalent in chapter 2, right? So for example, 1/2 is the same as 50/100, which is equal to 0.5, right? So 1/2 or 1/2 is the fractional equivalent of 0.5, okay, which is its decimal representation. So here it's telling you to try both decimals and fractions. So we know that 25% in its fractional form would be written as 25/100, and its decimal equivalent, we would just drop the percentage sign and we would move the decimal point 2 places over to the left, and we would have 0.25, okay? So to change 25% to its decimal equivalent, 0.25, you simply multiply 120 by 0.25, and then you press enter, right? And then to change 25% to its fractional equivalent, you would use your fraction key. And you press the fraction key, and then you enter your numerator, which is 25. You enter your denominator, which is 100. And then you multiply by 1, you press your multiplication key operation, you enter 120. So if you can see that here, you would, to enter this portion of the solution, if you will, you press the fraction key, and then you would see the cursor flashing on top of the numerator. You enter 25, and then you would press the down arrow to take you to the denominator, and then you would enter 100, and then you would enter the relevant operation. In this case, it's multiplication. Remember, I told you, I don't know if, I think it was the last lesson, but I mentioned that if you see of, that's usually an indication of multiplication. So here we're being asked to find 25% of 120. So we know that the operation here is going to be multiplication. So again, you press your fraction key. So the cursor will be blinking above the numerator. You enter 25. Then you press the down arrow. You enter 100. Then you press the right arrow to indicate that, okay, you're telling the calculator, okay, now I'm done entering my fraction, and my next step is my operation, which in this case is multiplication. You press the multiplication key, and then you enter in this case, this is the base, right? 25% of 120. So you enter your base, which is 120, and then you press enter, and you would see your answer on the right side of your display, which is 30. So using either the decimals or the fractions, you can find that 30 is 25% of 120. So again, going over the order of entry, if you will, you're being asked to find 25% of 120. We know that 25% can be written as 25/100, which is because 25% is essentially telling you 25 per, meaning over or divided by. Cent is short for, derives from the French word centime, which means 100. So 25, you can write 25% as 25/100, or you can drop the percentage sign and move your decimal point 2 places over to the left. And so 25% is can be written as 0.25, right? So if you chose to go the decimal route, the first time around, you would simply press the decimal point on in your calculator, and then enter 2 and 5, and then press the multiplication symbol, enter 120, press enter, and you get your answer, which is 30. Or if you wanted to go the fractional route, you would press the fraction key, which on your calculator is that raised key with the notation n over d, n being the numerator, d being the denominator. So you would press the fraction key, and then you would see your cursor blinking in the numerator on the left side of your entry window. You would see the cursor blinking in the numerator. You want to enter 25 in the numerator. Then you press the down arrow, and then the cursor would be blinking in the denominator. You would enter 100. Then you would press the right arrow to tell your calculator, okay, I'm done with my fractional entry. And the next entry is our operation, which in this case is multiplication. And it's multiplication because we see the word of. So you would press your multiplication key, and then you would enter the number 120, and then press the enter key, and then you would see your answer displayed on the right hand side of your display screen. You would see the number displayed as 30. So either using decimals or fractions, you can find that 30 is 25% of 120. And we know that because we've already discussed in chapter 2 that decimals are fractions. Decimals are fractional equivalents, and fractions are decimal equivalents. In other words, 0.25 is the same as 25 over 100, which is our fraction, which we can reduce further as 1/4, okay? And we also know that 1/4 is the same as 0.25. And if you want to help yourself visualize that, we can say that 0.25, we can represent that as 25 over 100, or we can think of it as 25 pennies over 100 pennies, or 25 cents, which when we reduce that, we get 1/4, which is a quarter, and that's where that terminology comes from. 1/4 is the decimal equivalent of 0.25, and 0.25 is the decimal equivalent of your fraction 25 over 100, or reduced to its lowest terms, 1/4. Or you can think of it in terms of the other direction. 1/4 is the fractional equivalent of 0.25. Okay, so if you multiplied either the decimal 0.25 or its fractional equivalent 1/4 or 1/4 by 120, you should get the same number. Why? Because the decimal 0.25 and its fractional equivalent 1/4 are represents the same quantity. Okay, and in this case, that quantity happens to be 30. So another way of thinking about this is, well, how many people, if we had $125, what portion of, like, if let's say you wanted to tip your waitress 25%, how much are you tipping the waitress if your bill was $125? was $120, and you wanted to be generous and give her 25% tip. Well, that number is 30, right? So that 30 represents 25% of 120, okay? Or you can think of that 25% as 1/4 of 120, which is $30. Or you can think of $30 as 1/4 of 120, right? And so I'm going into trying to use those quantities interchangeably to help you see that we're speaking the same language in terms of decimals and their fractional equivalents, right? And we're equating those as proportions, which we talked about earlier in this chapter, of the same quantity, right? So 1/4, 1/4 of 120 can be written as 25/100, and 30/120 can be written as 1/4, because 30/120, when you reduce it to its lowest terms, is 1/4, and 1/4 is 25%. So what am I doing here? I'm trying to help you recognize that everything that we're learning so far is sort of building up and helping you understand how mathematicians represent information, right? So we started off with the number line, and we looked at where 0.25 exists on the number line between 0 and 1, right? And we discussed how 0.25 is the decimal equivalent of 1/4, right? And we can represent that 1/4 as 25% of 1. And we can think of that, we know that every time we see percent, immediately we know that it's telling you that whatever number you're looking at is being divided by 100, with cent being the equivalent of 100, right? So again, all of that to say that when you see a quantity like this, instead of wasting time trying to write 25/100 and then reducing it to its lowest form, you can just immediately recognize that you can just drop this percentage symbol, move your decimal point over 2 places to the left. You immediately have your decimal representation, which is 0.25, and then you can multiply 0.25 by 120. And then you know immediately that if you remember from our table of equivalents that the book was telling you to memorize, the fractional equivalents that you see all the time, if you memorize that table, you immediately know that 25% is its decimal equivalent is 0.25, and its fractional equivalent is 1/4. Or essentially you're finding 1/4 of this particular number. And I always try to, as I tried to encourage you guys earlier in the beginning, if you have trouble visualizing, because it helps to visualize the numbers, you can think of it in terms of your everyday activity, right? So you ordered a pizza, you have lots of friends over, you spent $120, and the receipt is suggesting that you tip the driver 25%. Well, the receipt is essentially telling you, hey, give the driver 1/4 of this number right here, 1/4 of $120, which is $30, okay, or 0.25 of $120, which is also $30, okay? So when you use the percentage second function, the percent second function, you don't have to convert the percentage to a fraction or a decimal, because the calculator immediately already knows what it is that you're trying to do. So the example that follows just shows you, or is just showing you how we can practice using this function to find the part when you're given the rate. So in this example, we're being asked to find 65% of 360. I don't know if you can see it's a little bit, it's hard to see, but essentially we're being asked to find 65% of 360. So you're going to type the base, which is 360, right? And then you're going to press the multiplication sign, okay? And then you're going to type the rate, 60, you're going to enter the rate 65, and then you're going to press the second function key and engage the percent, okay? Second function, which is the key that's, when you're looking at the raised keys on your calculator, you'll see an open parentheses key, which is what this is. And right above the open parentheses key, you'll see the percent function, right? It'll be written in tiny font right above it. And to access that, you would need to press the second function key, okay? And then this open parentheses key, and that would bring you into the second function percentage zone, okay? To what this is explaining here. And then you can just enter, press enter, and you would get your answer. So again, all you would need to do, if you don't want to spend time figuring out what 0.65, what 65% is in its decimal equivalent, although I would say it's fairly easy. You just need to recognize that you're dropping the percentage symbol and moving 2 decimal places over to the right, which is 0.65. So I would say it's pretty easy to just enter 360 times 0.65. But if you don't want to be bothered with that, you can enter 360. Then you would press your multiplication key. You would enter 65. Then you would press the second function key. And then this open parentheses key, which takes you into the second function zone that immediately, what do you call it, adds the percentage symbol to your entry. Then you would just press enter and you would get 234. To me, that's a longer step, but you know, it's whatever you're comfortable doing. This is just helping you recognize that. If you don't feel like, you know, doing the step in your head where you're dropping the percentage and moving your decimal place over to the left, you can use this. There's an entry in your calculator that allows you to find the percentage directly, or to convert the percentage directly in your problem to get the answer. Okay. You can also use the percent function to divide to find the base when you're given the rate. So in this case, we were trying to find the part, but this is telling you that you can also use the same key to find the base. And that's also based on that diagram that we looked at, right? So if you're looking for the base, you would cover the base and you would have the part over the rate, right? So you would just enter whatever the number is for your part. You would divide by your rate. So if your rate was 25%, you would just enter 25 and then press the second function key, press the open parentheses key, which would automatically input your percentage, press enter, and you would get your answer. Or you can just immediately recognize that 25% is 0.25, and then you would divide your part, whatever your part is, by the rate, or you would just say, let's say your part was 5 divided by 0.25, and then you would get your answer. Or you can do 5 divided by 25, press the second function key, press the open parentheses key, which would automatically enter your percentage symbol, and you would get your answer that way as well. Okay, so I guess it's good for you to know that that option is available to you, especially if you see a percentage that maybe is not so comfortable, like if you saw like 345%, for example. Again, all you're doing is dropping the percentage symbol, moving your decimal place over 2 places to the left, so you would have 3.45. But you know, if you feel more comfortable, you can just use your calculator and you would press the second function key. You would enter 345, press the second function key, and then your open parentheses key, which would automatically input your percentage symbol, press enter, and there you have your answer. Okay. So this is just a tip telling you to practice using the delete key when you make a mistake in a problem, and the delete key will erase your latest entry, because you don't want to press clear, right? Because if you spent a lot of time, let's say you're working on a fraction, you recognize that there are lots of steps involved, right? First, you press your fraction key, you put in your numerator, your denominator, and let's say you put in your operation and the next fraction happens to be a mixed fraction, you would have to press second function and then press your fraction key and start with your whole number entry. And let's say in one of those steps, you made a mistake, you put in the wrong number, right? You don't want to press clear, because then that would erase all your entry and you'd have to start over, and the test is timed, right? So you don't want to waste time. So this is just telling you to practice using the delete key, and all you want to do is use your cursors to navigate to wherever you made the mistake. So maybe press the left arrow to move over to move 2 entries over, and then maybe the issue is in your numerator, so you would press the up arrow, and then you want to press the delete key, not clear, because clear would erase the entire memory. And you know, remember we started, I think that this example should have reminded you that you should press the clear key, because with every entry, or with every new problem that you're working on, you always want to press the clear key first to remove any information that might be in the memory of your calculator. Because remember, TI calculators, they're programmable, which means that they store information in their memory. So it'll store information in its memory concerning whatever problem you worked on last, right? So you always want to, even when you turn on the calculator for the first time, you always want to press clear to clear any information, or to remove any information that may be stored in the calculator's memory, and then you want to proceed with your new problem, right, with your new entries. So here it's just telling you that in the event that you're putting in your entries and you make a mistake, don't press clear. Just use your cursors to navigate to wherever it is that you made the mistake in your entry. Then press the delete key so that it only deletes that particular input that was wrong. And then you can put in the right information. And then you can use your cursor to navigate back to the end of your entries. And then continue with your entries, or if you're done with your entries, you press enter and to get your answer. Okay. So in this example, we're being told that Ned paid $150 for a stereo, and the amount that Ned paid was 20% of the original cost. And the question is asking you, what was the original cost of the stereo? So first things first, I would say clear, press clear so that you removed any information from your calculator's memory. And then you want to enter the base. And in this case, we know that the base is 150. So you use your digit keys, enter 150, and then press the division sign, right? Because in this particular example, we know that he paid 150, and we know that this 150 that he paid was a part. It tells us that the amount net paid was 20% of the original cost. We don't know what the original cost is, right? So in our little pictogram for our formula, we have the part, which is 150, and we have the rate, which is 20%, and we're trying to find the base. And so if I'm trying to show you where we are. So here we have the part, which is 150. We know the rate, which is, I believe it was 25%. So you're going to cover the base. And what this operation is telling you to do here is to divide the part by the rate to find the base, okay? So that's why we're dividing, not multiplying. So again, remember that you always want to consult your little pictogram there to kind of guide you in terms of what operation you should be using with your formula, okay? Yeah, so you're gonna enter, enter 150 and then press your division key. And then you're gonna enter 20, and then you're gonna press the second function key, press the raised open parentheses key to take you to the percentage zone, which is right above the raised key. And then you press enter, and you know that your answer is 750, which appears on the right hand side here. Or you can simply just enter 150 divided by 0.2, since we know that 20%, if we want to write it in decimal, you just drop the percentage, and again you move 2 places over to the left, and then you have your decimal equivalent for your, and just enter 150 divided by 0.2. Or you can go through the steps here as discussed to find 150 divided by 20%, and you should get the same answer, which is 750. So essentially that's it. Practice problems on page 715 to kind of go over your calculator skills. I think in this portion, it would just benefit you a lot to know how to work with or know how to find the decimal equivalent of your percentage. It's a lot easier than entering all those steps, but if you prefer, you can also just spend time getting used to putting in the entries so that you know how to do it so that you know how to do that as well on your test. So that's essentially it for today's lesson. Do you guys have any questions? Any portion of today's lecture that you want me to revisit?